I'll give you a time so that we start with it. And just put the text message here. Just say join now. Did we start?
Yeah, I texted her. So,
She has not yet joined.
mm-mm.
All right. So did you get the logic here?
So,
How to answer this question? How are you going to start answering it?
okay, I'll start with the given formula, which I must know, which is W omega naught, which is L over square root of LC, right? That's the given formula. And then we know from our calculation yesterday that change in W is L over R. So now Q equals to the omega naught over change in omega, which is given by 1 over LC, 1 over square root LC, all over L over R. So my problem is now after that, how did you do it?
No, this one, what they mean here on this formula, it's just Q. The quality factor is the same as L over R multiplied by 1 over root of LC. That's what they are just showing you there. So in other words, if you manipulate this, you are going to find out what is this L over R. L over, and also this W naught. What is it? W naught. This is what we are referring to as what? Angular resonance frequency, which is this simple. So if you manipulate this, you are going to get that. But from our answer, the change in omega was R over L. But here I'm not having R over L. I'm having L over what? Over R. So it's no longer multiplied by change in omega, but it's divided by what? Change in what? In omega. So that is the definition, change in omega, like that. So that is the definition of Q. Q is just this one. This is the Q which we are talking about. So the first thing is to just write your Q is equals to W what? Naught, which is the resonance frequency. That resonance frequency, we are dividing it by what? Change in what? Omega. Then we say it's equals to W naught. We are dividing by what? R over L. We are dividing by R over what? Over L. Forget about this thing. Forget about this. And forget about this. Take this. Just from there, you indicate W naught. This is the formula for Q, which is W naught over change in what? In W, which is equals to W naught over R over L.
Okay.
And when you do the inverse here, then that's when you are going to have, which is equals to W naught R is on the denominator. Any question? Must repeat again. Still, it does not stick in. Where exactly?
No,
Where,
no.
where exactly where we should clarify so that because you are going to compile the assignment and you must be able to understand like what we did yesterday. So if there's something that you are still not understanding, you say, check this formula which I showed you here for W naught, which was on the, yes, the angular, the resonance frequency, but this one was not given the resonance frequency, which I showed you, which was 1 over root of LC, 1 over root of LC. That resonance frequency, I think was page number 3. Yes, this one. Can you see this one? The resonance frequency.
Mm-hmm.
Yes. So there's no point for you to say you have been told that show that Q is equals to W naught, isn't it? Multiplied by L over what? Over R. So basically what they want you to know, they just want you to put the formula first. Q is equals to what? W naught divided by the change in what? In omega. This is how you find the quality what? Vector. Are we together?
Yes.
Yes. So already now we are introducing Q is equals to quality factor is equals to W naught, which is the resonant frequency over the change in what? The omega. Then from there, we are just putting this value. That's all. Then you're done. What you want to do. You can't do any answer, anything, because already you have shown. By you just mentioning that formula for quality factor, they are marks. Just mentioning those, it's marks. Just to say Q is equals to change in what? Equals to W naught over change in omega, that one. Already you have scored marks, just to remember that formula. By substituting, which means you are only substituting the denominator only, because W naught, you want it. Then you arrive at the answer. There's nothing there. There are no tricks here. No tricks at all.
I'm lost, Shem.
Where are you lost?
I'm lost
Because,
after.
yes.
So I understand up to where you're saying Q is L over R, square root of LC. That's I understand up to there where you have
Which one are you understanding? I am saying this step is irrelevant, this one, an irrelevant step. We
no,
don't need that step.
simplifying the
We
other.
don't need this one. We don't
Okay.
need those. We don't need this step. We don't need this one. The only steps that we need is from here, this one. Can you see this one? That is the only thing that we want. All these other steps, they are just going merry-go-round. We don't need them. They are not coming fast to where we want. We don't need those ones. The
So
only step
Ah.
that is relevant to us now is the formula first.
Okay.
Yes, that is the formula. That is the formula. Because here, they are now, we are given the formula that Q is W naught over change in omega. You just replace, like I told you, the next step, Q is equals to W naught divided by R over L. That is your next step. Then from there, you write Q is equals to W naught multiplied by L over R. We have shown. This is what we are going to be doing. That's all.
So the final answer, is it okay if I just write Q over W naught over change in omega?
For the final answer,
Hmm?
we are starting here, the step. This is the step.
Right.
This is the first step. From here, you go to the next step where you are replacing the what? The change in what? Omega. Then from there, it just have 3 steps. After you replace, now the denominator becomes the numerator L. That's what we are doing, because we are dividing. The denominator is now the numerator. And the numerator becomes the what? The denominator. That's what we are doing. It's math. When you divide by L over R, R over L is the same as multiplying by L over what? Over R, isn't it? Do you get the logic? When you divide by R over L, it's the same as multiplying by L over half. I mean L over R. Just like when you divide by 2 over 1, it's the same as multiplying by half. Dividing by 2 is the same as multiplying by half. So there are only 3 steps which you are doing. The other ones, they are just coming back. It's just a merry-go-round. You can't replace R, L over R, root of LC. Then you come back again to what you already replaced here, which is not relevant. It is not relevant. However, if you want to write it like this, you are still welcome. I can explain to you so that you see how irrelevant it was for them to go the long way. I can explain if you insist that you want to put even that working, it is there, but I can explain why. It's a repetition. It's just a repetition. It is there. They give you what omega, which you already want and which you are already looking for. Like on this step, we know that this omega is an equivalence of W naught is the same as 1 over root of LC. This is a formula that you must know. And also, this is a formula that you must know, which says Q is equals to W naught over what? Changing in W. So these are the 2 formulas which you are going to use. So here they just replaced W naught with the 1 over LC on this step, so the numerator. Are you following now? Then on the denominator, we have change in omega. Then that is R over what?
L.
Over L. So when you manipulate that, you are left with Q is equals to 1 over RL. So Q will be equals to 1 over root of LC. 1 over root of LC divided by what? RL. You are dividing by RL. Like that. Then when you multiply, which means you are going to use the inverse. Instead of dividing by RL, which means now we are going to multiply by what? What do I write here on the right? L over what? Over R. So your question was, how did they arrive at this point? From here.
Which point?
How did they come to the simplification from here? Is that the question?
So we took the formulas, we multiplied the 2 equations.
Yeah, we multiplied the 2 equations. Then they just rearranged. They just rearranged. They started with L, which means it's L over, instead of multiplying by root of LC, then they started multiplying by what? By R. And there's nothing wrong because multiplication is commutative. You can reverse the order. The commutative property of multiplication. So which means it's just the root of LC times R is the same as R multiplied by the root of LC. So there's nothing that they've done wrong. And then you manipulate again, which means now you want to take each term separate. L over R, you come and write, which is equals to L over R multiplied by 1 over root of LC. So still we are coming back to this point, 1 over root of LC. So why are you going all the way to come back and tell us this is W naught? So that's what I was saying, this is a repetition. So they've come back to tell us this is 1 over root of LC, which we should have put long time so that you save time rather than to just use a long method. So L over R is the same as what? 1 over change in omega. Then multiplied by 1 over root of LC is W naught, which is the resonance frequency. Multiplying the numerator as a fraction, denominator by denominator, what are you left with? Q is equals to numerator W naught, denominator change in omega, which is the same as W naught multiplied by L over R. So you just end at that point. You just end here where it says Q is equals to L over R multiplied by W what? Naught. That's what we've been told we are supposed to grow. So you choose any of the steps that you want. If you just want to use the short method here, straight away, just replace the value of change in omega, you get your answer there and then. So you choose the method that works the best for you. Should we continue?
Yeah, I think we can continue.
All right, number 3.
Mm.
So a harmonic oscillator with a mass m, natural frequency omega, and the damping constant R is driven by an external force F of t given by F naught cos omega t multiplied in newtons. So the N there is representing it's a force, it's in newtons. So write the equation of motion and use it to show that xp A sine omega t is a solution if A is equals to F naught over R W naught. So which means you are going to use your information or your knowledge about differential equations for particular solution. You've done differential equations, is that so? Did you do differential equation?
In calculus.
No, not calculus. Calculus is calculus. Differential equations is on its own. A differential equation is not calculus. However, there is calculus or a mix because there is differentiation, but these ones are differential equations where you are finding a general solution, a particular solution, a homogeneous equation. It's the first time to hear that. All right, let's solve it. So finding the equation of the motion driven by the oscillator and verifying a solution. That's what we are finding. We are looking for the equation of this motion that we have been given. Remember, the particle is having a mass m. So you are having your information, which is mass what? Mass m. Then the natural angular frequency, W what? Naught. So you must know the unit. The damping constant, R. The external force given by that function, F naught cos omega t. And the particular solution, which is given by A sine omega t. So this is just given information. Condition. We are told that this condition, we have been given a particular solution such that it must satisfy this condition. Can you see this condition which is given here? The condition that is given. Your A, the value of that A is equals to F naught over R multiplied by omega naught. That is the value of this A naught which is given for the particular solution. So first you write the equation of that motion. How are you going to write the equation of that motion? This is the standard equation of the motion. Mass times acceleration. Remember, we are just adding all the forces, all the sum of the forces. Remember from your metric physics, F net is equals to what? Mass times acceleration. Is that correct? F net is equals to mass times acceleration. Is that correct? Yes. So your mass times the acceleration plus R multiplied by the velocity, means the x double dot is the acceleration, and then the x dot is the velocity. So R times V, giving you another force. Then the constant of the spring constant K. But we know that omega naught squared is equals to K over M. So this you must also know. The spring constant divided by the mass, it will give you the angular frequency. So this is Ft, which is the force which we are given. Ft is cos omega naught multiplied by T. So once you have your equation, it's just a matter of substituting the value, the values there. So first we are going to differentiate. First time for x double dot, which means it's the second derivative. So those two dots are showing you that you must differentiate y. One dot is showing you that you must differentiate 1. So this is the value for W naught squared is equals to K over M. Then you are going to substitute what is the value of W naught using the particular solution. So now we are differentiating this particular solution once you get X dot. You differentiate the particular solution twice, you get X double dot. That's what you're just doing there. And then you replace into the formula. So let's differentiate that one. So this is our force Ft. We replace the force by F naught cos omega t. And we substitute where there is K. Now you replace K by saying K over M is equals to omega naught squared. So where there is K, you solve the equation by multiplying both sides by M. This is M, this is M. So K will be equals to M omega naught squared. So where there's K, you are putting now omega naught squared. That is the only changes that we have done. So we have replaced the F of T, we put cos. We have replaced K and then we've put M omega squared. Then from there, we differentiate now the particular solution. So the particular solution that we have been given is particular solution xp is equals to a sine omega naught t. So the x dot, which is on the equation of motion, we are differentiating xp once, the derivative, the first derivative. If you are having the x double dot there, which means you are going to differentiate xp twice, like that. That's what they are doing. So let's differentiate, we replace, when you differentiate a sine omega t, the derivative of sine is cos. And remember, it's chain rule. There is omega t inside. So we are going to differentiate that omega t with respect to t. Because omega is a constant, we are left out with only sine omega t. The constant comes out. The constant is omega. So that's why this constant is out. So first you write the derivative of sine is cos. So this is our first derivative, which is the x dot. Then you differentiate xp again twice, which means you are differentiating the first derivative. Already I have a, so I'm going to differentiate again this expression. When you differentiate it, it's going to be cos, you get a negative. When you differentiate cos, you are going to get a negative sine. There is omega t, then you differentiate omega t with respect to time, you are going to get this constant omega because of chain rule of differentiation. So once you are done, everything is now sorted. You are just replacing. Where there is m, you put your m. This is your m. Where there was x double dot, now we are putting the second derivative, which is this one. We are putting the second derivative, which is negative omega squared sine omega naught plus r x dot. Where there's x dot, first derivative, you are putting a omega naught cos omega t plus, where there is a kx, now we are replacing m omega squared x. So that's what we are going to write, plus m omega naught squared x is equals to the right hand side, which is f naught cos omega t. F naught cos omega t. Like that. Then you simplify the equation. Left hand side equals to the right hand side.
Is she sleeping?
I can hear.
Hmm?
I can hear that. So how can you sleep online? All right, it's fine. We'll continue tomorrow. Yeah, it's tired. She's tired. All right, let's stop here. We'll continue tomorrow. I can see you. All right, so I will end the meeting here. It's fine.
No, like it's like I think how can you sleep online?
Yeah, she's tired. She's from where? So what do you do?
I'm sorry, guys. Am I snoring or something?
No, you're not snoring. It's just that you can hear that you're sleeping.
It was a bad day today.
Yes, I will share the recording, but for number 3, you have not even. So we'll just continue with number 3 tomorrow.
Okay.
How many questions? There will be 3, 4. It's 5 questions, isn't it?
Let me check. I think somewhere there.
There are 5 questions.
Is it 5? No, it just says that write
What was
down.
the last? No, I mean the questions for that assignment.
It is 5 questions, and then
Yes. So we'll do number 3.
okay.
Because come on 7.
Okay, I'll try to be active tomorrow.
All right. Stop here for now. I will
Okay.
share it in the group.
Or even the one
Bye.
for yesterday.
Yes, I will share that one.
Okay, no problem. Bye.